short thing we will make up here geometry cleanups. After performing the geometry cleanups, we will go for meshing. What is meshing? Like in the first class, I already said what is meshing. Can anyone tell me what is meshing? Like Jessica and Ashwin.
Dividing the whole object into different small parts called elements.
Yeah. So what we are doing, we are actually whatever you said is correct only. It's dividing our part into a small elements. Okay, that is we can say as a machine. But why we are doing that?
Get accurate results on the entire body.
Yeah. See here, if we talk about two members are new here, so that's why once again I'm saying. See here, for example, if you have a part, okay, that part has infinite number of particles. Okay, the part has a infinite number of particles. Each part, whatever part it may be. So each part has that infinite particles are there. Now that each particle has 6 degrees of freedom. So here, if you go in space, every particle has 6 degrees of freedom. Okay, so those degrees of freedom we have to restrict. Means we have to stop those degrees of freedom. Then only we can exactly find the solution. Suppose if it is moving in the space, means it will not properly get solved. Okay, due to which what we will do means we will create some equations for those nodes so that it should not move in the space. So that is the reason it will create equations for that one and it will solve to find the solution. But if we have infinite number of particles, means it will create infinite number of equations which is not possible to solve in any software. Whatever software it will be, we cannot able to find the solutions. So in that case, what we will do means we will convert. Okay, we will convert that infinite particle object to finite element object, which we can say as a FEM or FEA. Finite element method, finite element analysis. These subjects, like this term you have listened in your academics. Okay, FEM, FEM, finite element method. See here, FEM and FEA both are same only. Just the difference you can find here is FEM we are saying in our academics and FEA we are saying in our in industries. Okay, that is the only difference you can find here. Okay. Now see here, finite element means we are converting our infinite particle to the finite particle so that we can able to count how many nodes are there and how many degrees of freedoms are there and how many equation it is going to create and how it is going to solve. Those things we have to find it. That's the reason we are doing the meshing work. Without meshing, we cannot able to solve any equation. Sorry, any problem. Meshing is compulsory here. Okay. After meshing, we will assign the boundary conditions. Okay, we'll assign boundary conditions. So these are the 5 steps are there in our pre-processing, which we can say as a complete input. The next one is processing. Processing in the sense solving. Nothing is there in this one. Software has some solvers. Like ANSYS itself is a solver. Solver means the thing which is solving your problem. That one we can say as a solver. So ANSYS itself is a solver. Apart from ANSYS, we have some more solvers are there, like LS-DYNA and some what are I am not really that like OptiStruct, Radios. These are the solvers are there which we are using for solving our equations which we are creating under pre-processing. So by using those solvers, we have to We have to use that one and we have to solve it. So the next thing is post process. Here, results visualization. Results visualization or optimization, we can say. Results visualization or optimization means here what we will do, whatever whatever the solver solve the problem, after that one we have to check the results. So while checking those results, that comes under and like some extension is under that one we will see the results. So that results, checking the results we can say as a post processing. And optimization means we are again, if any problem is there in the model, we have to modify that model till we will get some proper results. See, if I am creating any model means we are not doing only one time analysis and we are getting the output. It's not like that. Okay, sometimes it happens, but most of the time, multiple times we have to perform the analysis. Why? Because if it is going to damage, the part is going to damage, the deformation we are getting more, or we are getting the more stress, in that case we have to modify our model so that we will get a proper result. So in that case what we have to do, we have to perform the optimization work. Again we will remodel that one. Like we will add some extra things in that one, or we will remove some extra things from there. So like that kind of things we will do and we will make a proper model. That is my post process. Okay, so here in ANSYS also the same thing you can find here. If I go for any of the analysis, everywhere you can find the same options. For example, I am taking a static structure. The first thing, engineering data, geometry, model. These three are your pre-processing. Model, geometry and engineering data. These three are your pre-processing. Setup and solution. Setup. No, sorry. Setup. Till setup is a pre-processing only. Engineering data to setup, it's a pre-processing. Solution is your processing, and results is your post-processing. So in every whatever project or whatever type of analysis you are taking, everywhere you can find the same options here. If you go for model analysis, there also you can find the same. If you go for buckling analysis, you can find the same option. If you go for explicit dynamics, you can find the same option. And we will go for thermal, steady state thermal, you can find the same options. And transient structural, you can find the same options. Like every analysis, you can find the same option. Then the next one is transient thermal, you can find the same. And the next thing is transient thermal, static thermal, static structural, transient structural, then rigid body dynamics, harmonic response. So this much analysis we are performing here. Okay, this much analysis we are doing here in our ANSYS software in this course. First we will go with the static structural, then we will go for model, then we will go for transient structural, then we will go for steady thermal, transient thermal, explicit, and rigid body dynamics, harmonic, and finally we will go for the explicit dynamics. Explicit dynamics is your crash analysis. You have seen the car crash analysis now. That is your explicit dynamics. Under that one we will perform that analysis. Okay, so these are the analysis we are performing. This is our syllabus here in this software. So this all kind of analysis we will do, and under each analysis we will check one by one, like 2 to 3 problems we will do in each analysis, and we will check the results, and based on that one, see if you go for the company, the same kind of things only you can find. Okay, Yeah, that one. This is our mechanical kind of things. Like something you can find thermal, not thermal, like electrical, and the response spectrum, random variation, vibrations. Those are something different. Like it is related to vibrations, like earthquake. If an earthquake happens, so how the buildings, like it is related to somewhat civil kind of things. Response spectrum, random vibrations. Those two. It is related to civil. Yeah, this one. So these are our analysis we are performing here. Based on that one, we are getting the results. Okay. So tomorrow, what I will do, I will start the engineering data. I will check how to assign the different materials to our body. Okay. Any doubts still here? Sorry, today I've taken only half an hour class because I'm installing the software today. Due to it's taking some time. So tomorrow, directly we'll start the class at sharp 12 o'clock, and directly we'll start the class. Okay. Anyhow, the software is working nicely only in my system, so nothing to worry. Okay, guys.